Welcome back to Coding the Sounds of Music. In this video, we're going to talk about how to calculate the time interval for a note for a given tempo. Please make sure that you have your TI Nspire CX2 graphing calculator connected to the TI Innovator Hub using the unit-to-unit cable. Additionally, please navigate to Challenge 3 Background. That's probably on page 2.5. Remember to use Control ClickPad right and Control ClickPad left to navigate. Pause the video now, prepare your calculator, and resume when you're ready. In the last activity, we learned that a metronome is used by musicians to keep the beat of a piece of music. This beat is called tempo, and tempo is measured in beats per minute. We said that a tempo with 120 beats per minute means that you would tap your foot 120 times in 1 minute to keep the beat. When we start to write code in Python for making music, we need to understand and calculate how long one beat takes, because we're going to play a tone for however long that is. So we need to figure out how many seconds there are in one beat when the tempo is 120 beats per minute. We'll use that time in our code later, but right now we're just interested in figuring out how to calculate it. You'll recall in the last activity when we learned about the metronome, we said the metronome is like a swing set, and that the time that it takes for the swing to go back and forth is called the period. That's actually what we're calculating here, is the period for the tempo at a particular number of beats per minute. The way that we do this is using a straightforward formula, 60 divided by the beats per minute. So 60 divided by the beats per minute will calculate how long one beat will last, or the period of the beat. Let's go to the next page and see an example of this. Control ClickPad to the right. And here is an example of calculating the number of seconds for one beat when the tempo is 100. As I mentioned, all you have to do on your calculator is enter the number 60 and then divide that by the number of beats per minute in the tempo, in this case 100. 60 divided by 100, well, that's just 0.6 seconds. That means it takes 0.6 of a second for your foot to tap if you're tapping at 100 beats per minute. Or if you're a musician, it means that the note that you play, the frequency of the note that you play on your instrument, will last 0.6 of a second. So think of it like a piano key striking the string in the piano to make a note. That has to last just 0.6 of a second. It's kind of quick. One way that you can kind of think about this is that in this particular example, the reason that 60 is sitting there is because there are 60 seconds in a minute. And if we're using a tempo of 100 beats per minute, that means we're going to divide that 60 seconds into 100 equal parts. And so dividing 60 by 100 again is 0.6 of a second. Well, let's try using this formula one more time for some practice. To do that, I'm going to use a feature of the calculator called the scratch pad. If you look on the left, the second button from the top has a little icon of a calculator. I'm going to press that. And it pops up something called the scratch pad, which is a little calculator. And here I can do something like 2 plus 2 and hit enter, and it'll tell me the sum. Well, let's do a little practice problem. What if my tempo was 80 beats per minute? How would I calculate how long a beat lasts? Well, I'd use my formula. 60, I'd press the divide key and put in the tempo 80, and I'd press enter. It gives it to me as a fraction. It takes 3/4 of a second. And if I want to know what the approximate decimal value of that is, I would press the control key and enter. And that's 0.75 seconds. So the period of one beat when the tempo is 80 is 0.75 seconds. Now let's close the scratch pad by moving our cursor up to this big X using the trackpad and click to close. Let's go to the next page and read the instructions. Here are some instructions describing how to play a tone for a period of time. Remember, we learned in the previous challenge that the sound.tone method takes two arguments. The first being the frequency that is played for the tone, and the second argument or parameter is the time interval that it is played. There is a problem, though, when you start to write music and we start playing multiple tones or notes. And that is if you issue a command that lasts for 1.2 seconds, Python sends that command to the hub and it begins to play it. But then immediately it sends another command. Change the tone to 220 and play it for 1.2 seconds. Well, the hub's like, well, wait a second, I didn't finish my 1.2 seconds at 440. Give me a moment. Well, that moment needs to be added using a sleep command. And we're going to learn how to do that so that we can play this second tone, because after all, that's really what music is. It's a number of tones played sequentially at different frequencies for given periods of time. All right, let's go to the next page by pressing the control and click pad to the right. And here it shows us the solution to this problem. If we insert a sleep method, this is a method that just pauses the execution or running of the Python program, and it takes an argument of how long to just sleep or do nothing in seconds. So if I were to take my example from the previous page, which is playing two separate notes, and I were to insert a sleep in between them, this will allow the first tone to complete before playing the second tone. So this sleep is essential when playing sequential tones. Otherwise, all you'll hear is the last one, because the last one overwrites all the previous ones before they have an opportunity to play. Remember that computers and calculators and things like the hub, they do things very, very quickly, much faster than humans can. And so this command right here will overwrite all these other ones before they ever get a chance to do this. That's what the sleep's all about. This sleep is really for computers to sit around and wait for humans. All right, let's go to the next page. Control, click pad to the right. And here's our challenge. It says, let's play the orchestral tuning note 440 for one beat at a tempo of 100 beats per minute, 60 beats per minute, and 140 beats per minute. And then it says, use the sleep method so the entire note is played. And then use a second sleep method as a rest between the two notes. All right, let's think about all this. There's a lot to this. First off, orchestral tuning. Well, this is when you see an orchestra getting ready for a big event. You'll hear them all down there tuning their instruments, and eventually the concertmaster will play A4. And A4 is a note that everyone listens to in the chamber, and they all agree that their instruments play exactly 440 hertz, or A4, which is what's written in the music. And so this is a way for musicians to tune up before the orchestra begins. So that's what that is. A4 is just a musical notation for 440 hertz, that tone. Okay, we learned what a beat is. A beat is the period for the note to play at a particular tempo. So this is how long this note of 440 will be played. How many seconds that is. And we learned that the tempo is the number of beats per minute. That's how fast you tap your foot. So we're going to play this note at 3 different tempos. It's going to be the same note, 440, but it's going to be played at 3 different tempos, 100, 60, and 140. And then we're going to figure out how long that is, and we're going to sleep for that period of time, whatever this one beat of time is. Then we're going to add 2 seconds to separate out the 3 different tempos so that we can hear them. I'll help you get started calculating this first one of 100 beats per minute, and I'll do it using the scratch pad that we learned about before and our formula. So I'm going to press the scratch pad key, and I'm going to remember my formula. It's 60, and it's divided by the tempo, which my first one is 100. And I'll press enter, 3/5, and remember to get the decimal value because that's what you need to enter in your Python code. Press Control Enter, and it says it's 0.6 seconds. Okay? So what that means is I'm going to play 440 for 0.6 seconds, and then I'm going to put 2 sleeps in after it. So let's go ahead and do this. I'm going to go to the next page, and here is my hub import. I'll move my cursor using the trackpad all the way to the end, and I'll press enter to go to the next line. And I will then use my first command that I learned about earlier, the tone. So I'm going to go to menu, and I'll go to number 8, hub, number 2, built-in devices, number 3, sound output, and number 1, tone. I'm going to play a frequency of 440. For my calculated time for 1 beat at 100 beats per minute of 0.6 seconds. I'll use my trackpad to click once to the right to get out of the parenthesis, and then press enter. Now here come my sleeps. So I'm going to go to menu, and I'm going to go to number 8, TI Hub, and notice number 5 is commands. If I go to number 5, sleep is my first command, and I'm going to sleep for that 0.6 of a second. And what that does is it allows the hub to do its business of playing that 0.6 of a second 440 note by tuning A for 1 beat. So I'm going to press enter. Now is time for my second sleep. So I'm going to go to menu, and I'm going to go to hub, and I'm going to go to commands, and I'll go to sleep, and I'll put in my 2 seconds. Now you might be thinking, couldn't I just add those together and just sleep for 2.6 seconds? And the answer to that is yes. I did this just to make it clear of what we're doing. This is the sleep for the tone to play out at 1 beat. This is what is called a rest in music. In music, when you're playing tones, sometimes you'll insert a rest where nothing is played. It's just a time for the music to go quiet. So that's what we've done here, is we've used a tone with a rest. All right, well, I'll go ahead and play this for you, and then I'm going to leave it to you to finish this program. So I'll press Control R, And you may not have heard that, so I'll play it again real quickly by pressing Control R. And that was it. That was tuning A played for one beat. All right. So I'm going to go back a page. Remember, you can go back a page by pressing Control, arrow to the left, and here's my program. And now I'm going to hit Enter to go to the next line. And it's time for you to do the other two portions of this challenge. So if I go back to page 2.9, it says the remainder of the challenge is again to play 440, but this time it's 60 beats per minute and 140 beats per minute. So what that means you'll need to do is you're going to call up your scratch pad and you're going to calculate this time period right here using your formula 60 divided by the beats per minute, and you're going to enter that right here. So really these three lines are going to be exactly the same. The only difference will be you'll be changing these numbers right here according to your calculation for the time period for one beat at these different tempos, 60 and 140. So go ahead and pause your video now and take the time to finish the challenge. When you're all finished, go ahead and resume the video and we'll wrap this up. I hope you got your program working fine, and I also hope that you learned how it's essential to put a sleep command just after a sound.tone command. You need to give the hub time to play that tone. In addition, I hope that you learned how a rest works. Rests are very important in music, and they're essential in playing a song in Python. Well, that concludes this video. Please stay tuned for our next video, Musical Notes. I'll see you there.